Okay, I think we're going. You guys will have to excuse me if I sound frustrated here. I'm super frustrated right now. I've been recording this frickin' video all morning. It's now 9:30. I started at 7 a.m. and we keep having audio-visual difficulties. So apologies if I seem frustrated. I am frustrated with this. All right, I wanted to walk through an example of doing these joint and segment angle calculations in 2 dimensions. So let's suppose you do a motion capture experiment, and from that you get data that looks something like this. You have 4 markers on the body: a marker on the shoulder, a marker on the hip, a marker on the knee, and a marker on the ankle. For each one of those markers, you'll get their location on the x-axis in the lab in the global room here, and their location on the y-axis in the lab. And so that's what these data are here: S for shoulder, H for hip, K for knee, A for ankle, the X location of that marker, and the Y, the vertical location for that marker. So these would be data where, like, if I was the participant, if I was walking along here and you froze me at some particular spot and measured the X, Y coordinates of those 4 joints, you would get data that look like this. Okay? Now, from those data, from these numbers here, how do I, from these just simply coordinates, calculate the segment angles and then the joint angles? Let's walk through that process. First thing we want to do is draw a picture here to animate our data, to visualize our data. And it's important to draw a reasonably good picture here. It'll become hopefully clear a few steps down the road why having a good picture is important. So we're going to take some care here. First, let's draw a reference frame. So here's my origin. This is 0, 0. And then I've got my global x-axis plus x, and my global y-axis plus y. Okay. Then I'm going to draw my shoulder marker. It's 20 units in this direction, and 100 units, let's make that a little bit closer, 20 units here, and 100 units here. Okay. And then my hip is 18 units in the x direction, so it's going to be a little bit behind the shoulder, and 50 units in the y direction, so it's going to be quite a bit below the shoulder there. And then my knee is 27 units in the x direction, so it's in front of both the hip and the shoulder, so maybe about here. And then 25 units in the y direction, so about halfway down to the ground from the hip, right about there. And then my last one, my ankle, is a little bit behind the knee and just a little bit above the ground. So a little bit behind the knee and a little bit above the ground. Okay, so we drew our data here, and now we need to construct our linked segment model, which is a fancy way of just saying draw a stick figure. So I'm going to connect my shoulder to my hip, connect my hip to my knee, and connect my knee to my ankle. And to keep things uncluttered here, I left the foot markers out of the picture here, but if you wanted to visualize this a little bit better, you could draw a foot down here. Let's pretend we had like a heel marker and a toe marker, and connect those dots. So then we can just visualize things a little better, and this looks a little bit more like a single leg of a human walking in the stance phase here. Okay, with those data plotted here, the next thing to do is I want to calculate my segment angles. I have 4 joints here: shoulder, hip, knee, and ankle. In between those joints, I have 3 body segments. I have my trunk between my shoulder and my hip, I have my thigh between my hip and my knee, and I have my shank between my knee and my ankle. Okay, so I want to calculate those 3 segment angles: trunk, segment angle; thigh, segment angle; shank, segment angle. How do I do that? I go to the joint for each of those 3 segments. Each of them are comprised of 2 joints. And for each one, I go to the joint that's lower to the ground. So for my trunk, that would be the hip. And I draw my global x-axis here out to the right. Okay. And then I repeat that for my other 2 segments. For the thigh, I go to the lower joint, draw that axis out to the right. For the shank, go to my lower joint, draw that axis out to the right. Okay, then visually my segment angles are I start at that x-axis and I rotate counterclockwise until I run in to a segment, and that arc, or that angle that's swept out or subtended by that rotation, is the segment angle. So that's theta trunc. This one here, start at the x-axis, rotate counterclockwise until you hit a segment. It's theta phi. And same deal down here, start at the x-axis, rotate counterclockwise until you run into the segment, and that's theta shank. Okay. So visually, I'm done. I've got my segment angles here. Numerically, I'm not done yet. I still have to actually calculate the values of these angles from these data here. And how do I do that? The trunk angle is the inverse tangent of the x-coordinate for the hip. Sorry, not the x-coordinate, the y-coordinate for the hip minus the y-coordinate for the shoulder divided by the x-coordinate for the hip minus the x-coordinate for the shoulder. Okay. So why is it hip minus shoulder? Why isn't it shoulder minus hip? Doesn't matter. You could do shoulder minus hip if you want. If you did, you would just have to also do shoulder minus hip here on the bottom. Okay? So the important thing to remember about these equations for calculating segment angles is the y's have to go on the top and the x's have to go on the bottom. Okay? Don't put the x on the top and the y on the bottom, you'll get the wrong answer. The y's have to go on the top and the x's have to go on the bottom. Side to side, it doesn't matter. Okay? Here I did hip minus shoulder. It's hip and shoulder because those are the two joints that comprise the trunk here. So that's why it's hip and shoulder and not hip and knee or knee and ankle or something like that. But why did I do hip minus shoulder? I just did. It's arbitrary. You could do shoulder minus hip and you'd get the same answer as long as you also did shoulder minus hip here on the bottom. Okay? So the two things to make sure you keep straight for calculating these segment angles. The y's have to go on the top and the x's have to go on the bottom. And if you do joint 1 minus joint 2 on the top, also do joint 1 minus joint 2 on the bottom. Okay? If you do it the other way around, that's fine. You get the same answer as long as you do it that way on both the top and the bottom. So you can do shoulder minus hip divided by shoulder minus hip. That gets you the same answer as doing hip minus shoulder divided by hip minus shoulder. Where you would get into trouble is if you did hip minus shoulder on the top and shoulder minus hip on the bottom. Okay, that won't work. It's got to be the same order there, left versus right, on both the top and the bottom. But which one's first, which one's second, doesn't matter as long as it's the same on the top and the bottom. Okay, for the thigh, that's inverse tangent of y for the knee minus y for the hip divided by x for the knee minus x for the hip. And then lastly for our shank, that's going to be y for the ankle minus y for the knee divided by x ankle minus x knee. Okay. So always the change in y's divided by the change in x's, and always one joint on the left minus the other joint on the right, okay, regardless of which segment it is. So all you really have to keep straight is what two joints does that segment exist between. For the shank, for example, it's the ankle and the knee, and so that's why the data that I use to calculate that segment angle are the data from the ankle and from the knee. Okay. All right, after this, it's just plug and chug. Take these numbers here, plug them into these equations here. That would look like this if you're doing it in Microsoft Excel. So here I've copied those data from the marker board up there. And so let's calculate my, oops, it was already bolded, segment angles For the thigh, that would be the inverse, or sorry, not the thigh, the trunk is our first one. That would be the inverse tangent of the vertical hip minus the vertical shoulder divided by horizontal hip minus horizontal shoulder. That gives me 1.53 radians, and we tend to understand degrees better, so let's convert 1.53 radians to degrees. To do that, you take the 1.53, you multiply by 180, and you divide by pi. And that gives you 87.7-ish degrees for my trunk angle. Now, this is a good opportunity to do what I call a reality check. So we got 87 degrees there. And this is why it's important to draw a good picture of these things, because now we can check our answers and see if they physically make sense. My trunk angle that I drew here is this angle there, and is 87 a plausible angle for that? Well, 90 would be, if I draw my vertical axis here, 90 would be that angle there, right? That right angle between the horizontal, and global vertical. So my trunk angle here I got looks like it should be a little bit flatter than 90, and 87 degrees is indeed a little bit flatter than 90. So we passed our reality checker. This seems like it's a plausible answer. Okay, let's do our thigh angle. That's inverse tangent of vertical knee minus vertical hip divided by horizontal knee minus horizontal hip. Oops. Need an extra pair of brackets there. Gets me negative 1.2 something radians times 180 divided by pi. Gets me negative 70 degrees. Okay. So this is an important point here, this negative angle. Let's do our reality check to demonstrate why that's important. Notice here for my thigh, I got this big angle here. Okay? Is that angle 70 degrees? No, right? This angle here would be 90 degrees, and so my thigh angle should be something bigger than 90 degrees. Okay? So why did I get 70 degrees? Is Excel screwing with me? Did I make a mistake here? I put the wrong number in or forgot something? It's not wrong, it's just that Excel is thinking too much. It's trying to correct something or account for something that I don't want it to account for here. Notice there that the answer that I got was negative 70 degrees. So what Excel is doing in this particular case is it's not telling me this angle, it's telling me this angle. Okay? And how do I know that? Well, I know that because the value that it spit out was negative. And remember when we introduced the directions of rotations last time, we said counterclockwise is positive, clockwise is negative. Okay? So when Excel gave me a negative angle, I know it must be telling me this clockwise angle here, not this counterclockwise angle here. Now, I don't want that clockwise angle. I want this counterclockwise angle that I drew because this is the angle that I need to calculate joint angles eventually. I can't use these negative angles for joint angles. I'll get the wrong results if I try and use that segment angle to calculate my joint angle. So I've got to convert this negative angle to this positive angle. How do I do that? Well, that's done by recognizing that this is a half circle. A full circle is 360 degrees, so a half circle is 180 degrees. So these two angles add up to 180 degrees here. So I can convert this negative angle here to the positive angle by taking the negative angle and just adding 180 degrees to it. Okay, and that gives me my correct counterclockwise positive joint angle there. Or sorry, counterclockwise positive thigh segment angle. And let's do our reality check. Here's my angle. The value I got for it was about 110 degrees. That's a little bit bigger than 90, and so it passes my reality check. Okay, last but not least, let's calculate our Shank angle. That's inverse tangent of vertical ankle minus vertical knee divided by horizontal ankle minus horizontal knee. It's going to be 1.45, 1.46 radians times 180 over pi is 84 degrees. Let's do our reality check. Does that angle look like it could be 84 degrees? Yeah, it's a little bit flatter than 90, so that seems like a reasonable result. Okay, that's the hard part. Remember my joint angles. The reason I do the segment angles first is because the joint angles are easy after I've got the segment angles. So by having these three segment angles, trunk, thigh, and shank, I can calculate the angles of the two joints that are between those segments. I can calculate the angle of the hip, which is between the trunk and the thigh, and I can calculate the angle of the knee, which is between the thigh and the shank. Here I can't do the ankle angle because for that I would have had to give you coordinates for the heel and for the toe down here. So then you could calculate the foot angle, and from that you could calculate the ankle angle. So we're only doing hip and knee here because I didn't give you all the data you would need to calculate the ankle angle. So just to keep things reasonably short and kind of uncluttered here, we'll just do these two angles here. But the way that you would do this for the ankle would be conceptually the same. Now remember, my joint angle is the difference between the two segment angles that comprise that joint. Okay? My hip is comprised of my trunk and my thigh, and so my hip angle is just the thigh angle, 109, minus the trunk angle, 87. Similarly, my knee angle, knee is the junction between the shank and the thigh, so my knee angle is the shank angle minus the thigh angle. Okay. So I got 22 degrees for my hip angle and 25 degrees for my, or negative 25 degrees for my knee angle. When it comes to negative angles for joint angles, that's fine. Okay? It's okay if you get a negative angle for a joint angle. That's just telling you which direction's flexion, which direction's extension, or whatever particular joint you're dealing with. You don't have to add 180 to a negative joint angle to use that joint angle. Joint angles can be negative and positive, that's fine. The business where you add 180 to the negative angle, that's only for these segment angles and is done because you need them to all be positive to calculate the correct joint angles. But after you've done that, after you've made all these segment angles positive, it's still possible that you could get a negative joint angle, and that's fine. You don't have to adjust that negative joint angle. You don't have to add 180 to it. We just do that for negative segment angles, not for negative joint angles. Negative joint angles are fine for our purposes. Okay, that's an example walking you through like that. There's another example problem of this posted on the course website under the files, where there's one walking you through doing it in a similar style, but for the upper limb. And I'll post one a little bit later walking you through also how to do it for the ankle down here, just so we have a complete example of how to do this for all of our major joints here. Okay, that is it. Enjoy. Finally got it right here on the 5th try.